Okay, this is lesson 9.5, and it's going to explore numerical patterns, particularly in data tables. So we're going to use some word problems, make a data table, and then look at those patterns. Okay, let's unlock this problem. It says, on the first week of school, Joel purchases 2 movies and 6 songs from his favorite media site. If he purchases the same number of movies and songs each week, how does the number of songs purchased compare to the number of movies as we go week to week? So let's find our important data, our important information from the word problem. So it says here that Joel is purchasing 2 movies. I'm going to circle my numbers. And 6 songs. Okay. I'm going to underline my question so I know what I'm supposed to be figuring out. It says, how does the number of songs purchased compare to the number of movies? And we're going to write that in a phrase. So our answer is going to be a sentence. We're going to see how these two numbers compare as he purchases more and more movies and more songs each week. Okay, some keywords. So we definitely have each week. We know that every single week it's going to be 2 more songs and 2 more movies and 6 more songs. Some more keywords. This isn't an operation keyword. It doesn't tell us add, subtract, multiply, or divide, but we do want to make sure we stick with what number goes with movies and what number goes with songs. We don't want to mix those up. Okay, let's go ahead and solve. Evaluating this problem, I have some information about songs and movies. I know it's going to go up by 2 movies every week. It's going to go up by 6 songs every week. And I want to just compare these patterns. How are these patterns comparing to each other as they go? So let's go ahead and use a table to solve this. We're going to make a table where we have a row of movies and a row of songs. And the W1 and the W2 and these up here, these are standing for week 1, week 2, week 3, week 4. All right, and we're going to fill in this table. So if he's getting 2 movies every week and 6 songs every week, that means on week 1, this is the very first week he does it, he's going to have 2 movies, 6 songs, right? It's the very first week. He didn't have any before that. This is the beginning, so we're going to start with 2 and 6, okay? Then week 2, he's going to buy 2 more movies, right? Because it's 2 movies each week. So 2 more movies and these 2, that would mean he has 4 movies now. And then he's buying 6 more songs. With these 6 songs, that means he's going to add 6 again, and he's going to have 12 songs in week 2. So this data just shows in week 2, he now has 4 movies, 12 songs. Okay, and so let's go to week 3. So week 3, he does it again. He's going to buy 2 more movies. That means it's going to add on to this 4, and now he's going to have 6 movies. And he's going to buy 6 more songs, and we're going to add it to the 12 he had last week. So now he has 18 songs. Okay, do you see a pattern going on here so far? So right now I'm seeing 2, 4, 6. I'm going to guess this one's 8. In week 4, it's the very next week after week 3. I'm thinking this is 8. What do you think? It is, because 2 more songs added to the 6, it's going to be 8, right? And then we see a pattern in the songs too. We see 6, 12, 18, and then in week 4, he's going to add 6 again, and he's going to have 24. Okay, so our table is filled. We are not done though. We did not answer our question. We just have more numbers and more data to compare because our question says, how does the number of songs purchased compare to the number of movies? All right. So that means we actually need to compare. Well, we can compare movies to songs, songs to movies. They're going to compare to each other. We can write this saying, the number of movies is blank times smaller than the number of songs. We could say the number of songs is blank times larger than the number of movies. But what we want to do is we want to make a rule that says what these numbers are doing. So let's look at week 1. From 2 to 6. Comparing 2 to 6, let's see. I know that 6 is a multiple of 2. If I multiply 2 times 3, I get 6. And if I go backwards, if I say 6 divided by 3, I get 2, right? So I see that this is increasing times 3 going from movies to songs, or divide 3 going songs to movies. But I'm seeing, like, if I times this by 3, I get this. Okay, I could also add 4 to this and I get this, right? So it's got to be, we got to look at what's going on here. Let's look at week 2. Week 2, we got 4 and 12. How do these numbers compare? Okay, 12 is bigger. It's 8 units bigger. So if I add 8, I can get 12. But I didn't have add 8 over here. I kind of want the same rule going to each week so I can write this like overall rule of what's going on. Let's see. I did say times 3 over here. If I times 4 by 3, do I get 12? Yes, I do. So 4 times 3 is 12. 2 times 3 is 6. Okay, so times 3 works for both of those. I'm kind of thinking maybe times 3 might be it, but I've got to check it with the other ones. What if I do 6 times 3? Is that 18? Yes. What if I do 8 times 3? Is that 24? It is. So all of these, if I do times 3, if I do this number on top, the movies number, and I times that number by 3, then I get the songs number for every single one of these week data sections. Okay, so my rule is actually going to have something to do with multiplying by 3, but I'm not just going to put multiply by 3. I'm going to actually make it a sentence. I'm going to say, what do we multiply by 3? So we're going to multiply the top number, all right? The top number is the amount of movies. So multiply the amount of movies by 3 to get that bottom number, right? So to get the number of songs. All right, and that is my answer. My answer is to come up with a rule. How do these numbers compare? That was my question up here. How do the number of songs purchased compare to the number of movies purchased? Well, every single one of these, every week, each by week, if you times that top number by 3, you get the bottom number. And instead of just saying multiply by 3 or multiply the top number by 3 to get the bottom number, I'm actually being more specific by saying, what was the top number about? It was about movies. So multiply the amount of movies by 3 to get the number of songs, which is the bottom number. Okay, so we unlocked that problem. That's one example of how we look at number patterns to help us create rules going on in the data tables. Here's another example. It says, for each new level in a video game, a player earns 3 extra lives and 6 gold coins. Write a rule to show how they relate. All right, so I've got my table started. We have extra lives row, and we have a gold coins row. Okay, these numbers up here, L1, L2, that stands for level 1, level 2, level 3, level 4. Okay, this is new. These are called, ellipses? Ampersands? No, not ampersands. But these are, dot, dot, dot. It's kind of like a pause, right? Or continuing. We use it in our writing sometimes. In a table, it means that we're skipping some numbers. So notice I went from level 4 to level 8. So I skipped 5, 6, and 7, okay? It's kind of like I'm skipping over some numbers. We use that in math to show that, that skip, okay? We're going to get to level 8 in a minute, and it has to actually do with the question down here. But let's go ahead and fill in these first 4 levels using the data from the word problem to create a rule. Okay, so it does say, let's circle my numbers. I get 3 extra lives, 6 gold coins for each level, each new level. Ooh. Okay. And I want to write a rule. So there's no question to underline, but it is telling me what I need to do. I need to write a rule to show that how these numbers relate after I fill in the table, of course. Okay, we got 3 extra lives, 6 gold coins. So in level 1, his very first level that he passes, this player is going to get 3 extra lives and 6 gold coins. It's his first level. He didn't have any before that. As for extra lives, I'm sure he had lives to start with to play the game, but extra lives are always, a bonus to the lives you were already given. But he has 3 extra lives and 6 gold coins in the first level passed. Then he passes the second level, and he's going to add 3 more to that first 3. So now he has 6. And then he's going to add 6 gold coins to that first 6. So he has 12. Okay. So this top row is going to go up by 3. Every level he passes, he gets 3 more extra lives. So from 6, it goes to 9, right? And I'm going to go and do this one. From 9, it goes to 12. Because those go up by 3. Every new level he passes, he gets 3 more extra lives. Let's go to the gold coins. He had 12 gold coins. Remember, he's getting 6 for every level, so he went from 6 to 12. Next will be 18 in level 3, and next will be 24 in level 4. Okay. Now, we don't want to just go ahead and do, 3 more from here would be 15. I'm not going to put 15 here because remember, I skipped some levels. I'm going to do that ... up here too. I don't have level 5 next. Level 5 would be 15, but it's level 8. So we don't want to get carried away with writing our multiples in the chart, especially if we see an area where it's skipping some numbers, okay? Remember I said we're going to get to this level 8 in a minute. I think I have enough information here to write my rule. Okay, something kids like to do is they go, oh, it's plus 3 because I added 3. For each new level, he had 3 extra lives. But remember, we're not looking at only the extra lives. That would be only looking at extra lives. Okay, and we're not going to say, oh, the rule is add 6 because we're not looking at only the gold coins. We want to write a rule that shows how the extra lives and the gold coins relate. So we want to look from this number to this number. From this number to this number. How do those relate? What's going on? How do I get from 3 to 6? Okay. How do I get from 6 to 12? How do I get from 9 to 18? And we need to find something that's going on for all of these levels, something that's the same. Okay. So let's think. From 3 to 6, I can add 3 or I can times 2, right? So let's try those on this one. Can I add 3 to get 12? No. Can I times by 2 to get 12? Yes. So times 2 works on this one. 3 times 2 is 6. 6 times 2 is 12. Does times 2 work on this one? 9 times 2 is 18. Yes. 12 times 2 is 24. Yes. So my rule must have something to do from this row to this row. I'm timesing by 2, right? Multiplying by 2. I'm not just going to put multiply by 2. I'm going to write a sentence that relates the numbers. So what am I multiplying by 2? I'm multiplying this top number, extra lives. So multiply the extra lives by 2 to find, or to get, you could have put to get, the bottom number. So top number times 2 to get the bottom number. Multiple lives times 2 to get the gold coins, to find the gold coins. All right, so there's my rule and my almost filled in all the way table. But I'm going to go a little step further this time on this example. So now that we know this rule, we can actually use it to figure out how many extra lives and gold coins this video game would give us by, any level after that. If I know how many extra lives are given in that level, or if I know how even what level I'm on, I can use that pattern, that rule, to find out what these 2 blank missing numbers are. Okay, we are going to have to do a little bit more work at the table there. We're going to have to look for one more pattern. So we're going to actually look at how do I get from level 1, this is a number, right? 1 to 3, and 2 to 6, and 3 to 9, okay, and 4 to 12. Is there another rule that tells us the level number to the extra lives? Okay, 1 to 3, I can times by 3. 2 to 6, I can times it by 3. 3 times 3 is 9. 4 times 3 is 12, right? So I have another rule that helps me get from my level number to my extra lives number, and that's times by 3, right? So now that I know both of these rules, I can actually fill in this table and I can answer this question down here. It says, how many extra lives would be earned in the 8th level? So I want to know this number for that question. I don't need the gold coins number. I might find it for us anyway, because then my table would be complete. But to answer the question that they're asking me, I only need to find the extra lives of level 8. All right, so let's go ahead. We use this rule. So if we're on level 8, we're going to times level 8 by 3, and that gives us 24. Okay, and there's our answer for the question. So there are 24 extra lives in level 8. Woo. All right, so there's my answer to the question. I want to finish this off just because, completion. But to find the gold coins in level 8, even though it's not part of my question, 24 times 2 is 48. And now my table's complete. And example 2 is done. There's two more examples. All right, this one doesn't have a word problem with it. It actually has tables that are almost filled in all the way. We just have to find the one missing number and write a rule. Well, first we need to write a rule to figure out what's going on, and then we're going to use that rule to find that one missing number. Okay, so it says up here in the directions, complete the rule for the given table, then use the rule to find the missing value. So let's look at just example 1 table. Let's make sense of it before we just jump right into looking at numbers. What do these numbers represent? So the very, very top is the day. So day 1, day 2, day 3, day 4, ... So we're skipping. And then day 8. All right, then we have number of books, 3 books, up to 6, up to 9, up to 12. So they're earning like maybe 3 books each day. So each day that goes, they're getting 3 more books. And then amount spent. So they're spending money on these books. These aren't given to them. They are paying for them. And so 3 books was $12. 6 books is $24. It looks like they're spending, $12 more each day. Okay, so we got an idea of what's going on. They're buying some books. Looks like it's 3 books a day, and they're $12 every time he buys 3 books. We need to find a rule that satisfies how do we get from this top number to this bottom number. Okay, we can't do add 3 because that only compares the top row. We can't do add 12 because that only compares the bottom row. We want to find this row to this row, right? This row to this row. So how do I get from 3 to 12? How do I get from 6 to 24? And I want to find the same rule that's going along this whole table to use as my rule. Okay, how do I get from 3 to 12, guys? How do I get from 3 to 12? Let's see, 3 to 12, I can do 3, 6, 9, 12. That would be times 4. That might be it, right? Let's test it on the other numbers and see. 6 times 4, is that 24? Yes. Let's try it on this one. 9 times 4, is that 36? Yes. Let's try it on this one. 12 times 4, is that 48? It is. So times 4 or multiplying by 4 works, then that is my rule. I'm going to go over here and write my rule, multiply the number of books by blank to find the amount spent. We're just going to fill in by 4. We multiplied by 4, and now we're going to use that rule right over here in the missing number, times by 4. And 24 times 4, I don't know if I can do that mental math, so I'm going to do a little side work. 24 times 4, let's see, 4 times 4 is 16. 4 times 2 is 8, plus 1 is 9. So 96 is my missing number. And I'm done with example 1. Okay. Now, I'm actually going to show you example 2. Here it is. But this one's going to be on you to solve. I'm going to let you go ahead and try and solve this one on your own. You can put, what you think your answer is in the Google Classroom comments, or if you're using Flipgrid, you can record yourself answering the problem and telling your teacher about what you're thinking through and what you're doing, just like I did on the last examples. But let's look at what it is. So we have batches, number of eggs, and muffins. So I'm going to guess that this person is making some batches of muffins. Remember, batches is like, they made some muffins one time and then they made them again and then they made them again. It's like doing it over and over again. When you're baking, you're making batches. Okay, so for one batch of muffins, it takes 2 eggs and they get 12 muffins. For 2 batches of muffins, you need to use 4 eggs and it makes 24 muffins. Okay, so those are our numbers. That's what they represent. You need to find some rules, right? You need to find the rule that explains how many number of eggs to find the number of muffins. You need to find that rule that goes from this top row to the bottom row, from this number to this number, right? And it's got to apply to all of them, okay? Good luck on example 2. I can't wait to see some of your guys' answers and your reasoning, and talk to you guys soon. Bye.